Okay, so let us start with lecture number 36. Now, this module which we are going to cover is module number 5. Okay, in module number 5, we have BJT operation, their configuration, that is common emitter, common base, common collector, and also we have DC biasing. Okay, so the first category covers the basics of the BJT. The second category covers the application, that is 5.1 and 5.2. So 5.2 covers applications such as BJT as electronic switch. Current amplifier is not there. It covers BJT as an electronic switch and voltage amplifier. Okay, you have heard of this or studied this device ever before? No. Okay, so listen very carefully. First, write down the BJT full form, that is bipolar junction transistor. Do you understand what is a unipolar bipolar? Diode is a unipolar device. It conducts it conducts the current in P to N. Okay, not the other way around. Bipolar means it conducts in both the directions. Okay, so BJT is bipolar junction transistor. It has been, a lot of years, more than 6 or 7 decades before it was invented in Bell Labs in 1948. So it is long time back. All right. There are two types of BJT. One is NPN BJT. Other is PNP BJT. Please write it down. In NPN BJT, majority carriers are electrons. In PNP BJT, majority carrier are holes. Okay. Are you ready? Now I'll explain the construction and the working. Working a little later. First the construction, what is made up of. Let me expand it a little. Types understood, the full form of BJT. The meaning of it, bipolar junction transistor. Bipolar means it conducts in both the ways. Two types are NPN and PNP. And this is resembling your PN junction diode, that NPN. Here we have PN. Here see, this is one PN junction diode, this is another, right? This is one PN junction diode, this is another. So it consists of PN junction diode only. Concept is similar. But the structure is different. So this is how it will be explained. Okay. So here we have it divided into 3 parts. Emitter, base, collector. Okay. So here is my emitter. Emitter, let's say we consider NPN BJT. So this is N type. Then we have base region. This is my base. This is P type, and this is my collector. So please draw the diagram along with me. This is emitter, base, collector. C, T, B, short form. So this is my emitter, collector. Please pay attention because it's a new concept. Okay. Ron, now what do you notice over here? This is plus plus, this is plus, and this is N. What do you mean by plus plus? Heavily doped. Okay. Let's say the number of charge carriers, that is electrons, are 10 raised to 12, in the range of 10 raised to 19 over here per centimeter cube. Here there are less, 10 raised to 17, let's say, and here it is very moderately doped. Okay, atom concentration is 10 raised to 22, and here the impurity concentration is there, N, P, N. Normally we don't write N plus plus, P plus and N. We normally write NPN. But for your understanding, I'm explaining you. So emitter, this is my emitter, right? My emitter is very heavily doped. Base is, as you can see, the thinnest, having the smallest area. Okay, it's moderately doped. And collector, what they can say about the collector is very, very large, but concentration of carriers is very, very light, around 10:16. Okay. So, do you see there is a PN junction between base and emitter? Base and emitter. If you see base and emitter, we have PN junction. So, here is my depletion layer. Depletion layer is there now? You know how the formation of a depletion layer is, right? So, here is my depletion layer. Okay, this is called as depletion region. And this region is called as, let me just write this down. This is called as base emitter junction. We call it PN junction, right? So here we have between base and emitter a PN junction. Okay? Understanding? Now we have another PN junction. This PN junction is P plus and N plus plus. So here we have P plus and N plus plus depletion, PN junction form. Then there is another PN junction form between base and collector. Okay, so base and collector, since base is lightly doped, you tell me if base is lightly doped, collector is lightly doped, base is moderately doped, the depletion region will be more in collector side or base side? Remember in Zener diode, it was heavily doped, so depletion region was very thin. Okay, so collector is the lightest dope. So what will happen is, here the depletion region will be extending like this, and here it will be more. Understood why? Because it is lightly doped. Okay, so this is my another depletion region. And this depletion region, this junction is called as base collector junction, which is formed between P plus and N regions. Okay, have we drawn the structure? Draw the structure and explain the construction. It consists of N, P, N, where emitter is heavily doped, base is lightly doped and having the smallest area, collector is having the largest area and it's lightly doped. Okay, and it has three terminals named as emitter, base, collector. It has two junctions named as base emitter junction, base collector junction. The entire working is based on these two junctions. Understanding? Okay. So this is NP and BJT. Similarly, PNP, BJT will be how much? How it will be, instead of NP, you write PNP. Here the majority carriers are electrons. In PNP, the majority carrier will be holes. So I'll be explaining you all NPN. In the exam, they can ask you anything. So just reverse electrons with holes. That's it. Rest will be similar. Understood? Have you drawn the structure? Okay. We should know the PN junction background. What is the PN junction background we should know? In a PN junction, when it is forward bias, the depletion region with W decreases and my current increases, right? When the PN junction is reverse bias, its depletion region with increases and the current is very, very less in microamperes. So this is what you should remember. Okay, in forward bias, it conducts the current, and in reverse bias, it does not allow the current to flow. All right. So right now it has three terminals and two junctions. Three terminals are named as emitter, base, collector, and two junctions are base emitter junction and base collector junction. These are just the whatever I've told you. Emitter is heavily doped, base is lightly doped, and collector is moderately doped. Yeah, we can say that, but these are interchanged actually. This is moderately doped. Yeah, correct. It was correct. Why, I will tell you. See, I'll give you an example. Listen carefully. If there are 100 people in this room, the place is filled. Okay? Now, in the same space, there are 50 people. The room will look empty. Understanding what I'm saying? Now this room is half. This room is cut into half and there are 100 people. Now it will be look very, very heavily filled. Okay. Now the place is half, the room is half. The place will be looking like 100 people in full classroom is equivalent to 50 people in half classroom. Are you understanding? So the base region is so thin, let's say it's in the ratio of 1 is to 20. The base width is 1 and the collector width is 20. So base पे the concentration of carrier is more. But if we extend the base region to collector region, it will be lightly doped. समझ में आ रहा है what I'm saying? नहीं समझ में आया? Okay. Yeah. Whatever base region has the carriers, the concentration of charge carriers, if we extend it to collector ka length, it will be lesser. But since collector is larger, and if you collector ka, if I divide this classroom into 4 parts, if there are 100 people standing, and now those 100 people can stand in 1/4 of the classroom, it will be very, very crowded, right? So that is exactly happening over here. So we can say that the base overall, given the area, the smallest area is moderately doped, or we can say in the same context is slightly doped also. No problem at all. Both are actually true. And the base is narrow width and the collector is wider width in the sense of area. And what is my depletion region over here? Width. Actual base width is this. W. This is W. Okay. Now let's draw the symbols of both NPN and PNP. This is very important. Draw it along with me. It is drawn like this. Okay. This is called as base terminal. This is called as collector terminal. This is called as emitter terminal. This is NPN BJT symbol. Please draw it. The arrow indicates the current flowing out of the emitter terminal. Arrow in terminal indicates the conventional current flowing out of the emitter terminal. The arrow is there now at the emitter. It indicates that the current is flowing out of the emitter terminal, conventional current. Acha, how does the electron flow if a conventional current is flowing out of emitter? That means electrons are flowing into the emitter. Then draw PNP symbol. PNP symbol is exactly opposite. Wherever there is an arrow, that is emitter. This is base, this is collector. So in PNP transistor, the current is flowing into the emitter. Okay? BJT symbol is clear? Now tell me, PN junction has how many modes of operation? 2. Either it is on or it is off. Correct? Have you drawn the symbol, everyone? Yeah. Now write down regions of operation or modes of operation of BJT. Modes of operation of BJT. Write down, please. There are 4 modes of operation for a BJT. First is active region, cutoff region, saturation region, and inverse active region. Please write all of them and make this column. Write there base emitter junction status and base collector junction status. There are 4 regions of operation: active, cutoff, saturation, inverse active. Out of this, inverse active we don't use it and it's not there for you all also. So the 3 regions of operation are active region, cutoff region. Actually, sometimes in the books it's called as forward active. Cutoff region, saturation region, and inverse active region. Have you drawn that columns? Base collector, BE stands for base emitter junction. BC stands for base collector junction. I hope you will write the full form in your exams, not this BE and BC. Once you write the wordings, then you can use BE and BC. Okay? Now, listen carefully. In the active region, the base emitter junction is forward bias. So forward bias I'm writing as FB. Okay? And base collector region is reverse bias. In cutoff, both are reverse bias. In saturation, both are forward bias. And inverse active is reverse of it. So here, this is reverse bias, this is forward bias. So write down. You write it proper wording in the exam. Forward bias, reverse bias. In the active region, base emitter junction is forward bias, base collector junction is reverse bias. In cutoff, as I've written over there, the BJT is absolutely off in the off state. In the off state, both the junctions are reverse bias. And in saturation mode, the BJT is fully on. So when the fully on mode, your base emitter junction and base collector junction, both are forward bias. Easy to remember. Only you have to remember active region, that's it. Cutoff may it's off, so both are reverse bias. Saturation may it's fully on, so both are forward bias. Active may it's forward and reverse bias. Now, this is interesting. In active region only, when I use my BJT in the active region, it can be used as an amplifier. Now you have an application BJT as an amplifier, so it will only operate in the active region. And what is switch? What is the switch on and off, right? So BJT is used as a switch when it is used in the cutoff and saturation region. Okay, so somewhere where the way I have written, you can also write it down. And, in the active region is used as a amplifier, and in the cutoff and saturation is used as a switch. Completed? And inverse active is not really used for your. Okay. Now next, construction is over, types are over, symbols done, modes of operation you have written it down. Now let's come to the working. What are these active regions mean? Done, completed? Now, what is active region? Active region is this way, that base emitter junction is forward bias. What do you mean by forward bias? P2 positive supply, N2 negative supply, right? And what is the base collector junction reverse bias? Wherever P is there negative, wherever N is there positive. So this is my NPN transistor in the active region. So draw it please quickly. Draw it on the left hand side and right hand side draw it for PNP. This is for active region. Draw the structure. Now, if you have completed this, on the right hand side, you draw the structure for PNP transistor and do the active region ka biasing. What I mean is this. This is PNP, right? So here also this is forward bias, reverse bias. Completed this? If they tell you, mostly it is there is a possibility from experience I am telling. It will come. It might come in a short note. Write a short note on BJT. So whatever I have discussed so far, you can explain that also. Okay, done. Then cutoff region. No need to draw. Just see now. Only once you have drawn, right? Cutoff may both are reverse bias, and in saturation both are forward bias. That's it. It's the way you connect the battery. P to N, you connect the P positive and N negative. So both are forward bias in saturation region. Okay, no need to draw now. And for P and P, it's a reverse. P and P. So your forward bias is like this, your reverse bias is like this. So you have only drawn one, right? That is mode and sufficient in active region. Okay. Now next, I have already explained the word bipolar, right? Bipolar means charge carriers of both polarities, that is electrons and holes, take part in current conduction process. Agree? Okay. Now, what is the principle of BJT? Write down this as it is. Write down this as it is with the way I've written over here. Principle of BJT is it involves the use of voltage between two terminals to control the current flowing in the third terminal. It involves the use of voltage between two terminals. Which two terminals? Base and emitter. I have written the voltage VP to control the current flowing in the third terminal, that is collector current. So you control the voltage between base and emitter, and you can control the current flowing through the collector terminal. Okay? Completed? Okay. Then next topic is BJT configurations, very important. Write down BJT configurations. First configuration is common emitter, short form CEE. Second is common base, and third is common collector. Please write down quickly. See, modes of operation of the BJT was different. Configurations are different. Configurations are basically for BJT to use as an amplifier. So first is common emitter, next is common base, next is common collector. Okay, I mean it's just the names of three terminals, right? Common emitter, common base, common collector. Okay, completed? Now, don't draw this, I'll be explaining you in briefly this. Just I'm explaining in common emitter, emitter terminal is common between input and output. Basically, we want to use as an amplifier, right? What is an amplifier? An amplifier is a device. Let me tell you as a black box. So amplifier is a device. Let's say this is an amplifier. What an amplifier should do? If it is a weak signal, it should make it strong, right? So amplifier has input, it has output. So if you want to use BJT as an amplifier in common emitter mode, emitter terminal is common between input and output. This is my CE configuration. Okay. In case of common base terminal is common between input and output. Okay. And in common collector terminal is common between input and output. That's the meaning of it. All this I'm going to discuss in detail. Don't worry about it. You have to just remember there are three configurations: common emitter, common base, common collector. Okay. Next, write down working of NP and BJT. This is important. Very, very important. And we will use common emitter configuration. Write down the heading as it is. Don't draw anything, don't write anything after the heading. I'll explain. After the explanation, you can draw the diagram. First, understand how this works. Okay? Can I begin? Everyone ready? Now, please concentrate, or else you will miss out on this. Now, first thing is in active region likha hai na? So in active region, what are the two conditions satisfied? Base emitter junction should be forward bias and base collector junction should be reverse bias. Correct? So I have drawn it like this. These are, this is my emitter region, this is my base region, and this is my collector region. This is emitter, this is base, this is my collector. Can you see this together? I have drawn a bigger diagram, that's why I have to, do this. Okay. Now, let us start with the working. So, first of all, polarities. How will be the polarities? Base emitter junction should be forward bias. So, here positive supply is connected to, this is P region, and negative supply is connected to N region. And here, instead of directly connecting it to collector and base, you connect it across collector and emitter. There is a reason to it. You just listen right now. Instead of connecting directly power supply to base and collector, we connect it to collector and emitter. Indirectly, it will make so that base collector is reverse. I'll explain how a little later, but just now you believe this. So, what is VBE? VBE is VB minus base voltage minus emitter voltage. VC is base voltage minus emitter voltage. So, emitter terminal is common, right? That's why it is a common emitter configuration. Now, just listen carefully. In a PN junction, if it is forward bias, what happens? What happens? Only concentrate on PN junction now. This is my PN junction, right? Emitter and base junction are PN junction. What will happen to the PN junction? Base is slightly doped. Emitter is very heavily doped. You know why it is called as emitter? Because it is the source of electrons, emitter. Source of electrons is emitter. Now, if this is positive, this is negative, what will happen? There are lots of electrons over here, tied in very small space. And there are very less electrons in very small space over here. What will happen? Tell me. All these electrons will go to the, where they will go? To the base region. You imagine in the emitter region, there are 10 lakh electrons ready to move out. And in the base region, let's say there are 1000 holes. Holes are majority carrier in base, right? So what will happen? Some of the electrons, when they meet the hole, they can recombine. They can recombine and they can become neutral. But 1 lakh, 1 lakh bola ki 10 lakh bola? 10 lakh electrons are traveling from emitter to base, and only 1000 of holes are there. So few of them will recombine with the holes. Most of them will be traveling towards the collector. Why? Tell me why. They have to go somewhere, right? Electrons cannot stand in midway. They have to go somewhere. So where they will go? They'll go towards the collector, because collector may you have, it will be attracted towards this positive supply. So those electrons, and they will join the emitter, the electrons over here. See, here also there are electrons. Here there are, let's say, 10,000 electrons. Here there are 10 lakh electrons. Here there are 1000 holes, and there are and then 10,000 electrons. So all these electrons which are traveling, most of them will be flowing into the collector region. Now, how they will enter the collector region, that's a different story, but they'll go into the collector region. So basically, we can say 5% of them flow to the base current, it will contribute to the base current. 95% of these electrons will flow to the collector. Now, what will happen to these holes? Now, some of the holes will also go to the P region, right? And the number of holes going to the P region, they will contribute towards base current. Now, base current, that's why it's very, very small. Few of the holes will also travel back, because these holes will also be attracted towards the negative part of the supply, but most of the majority of the electrons will flow to the base. Now what happens is, base region is very, very thin, right? So the moment 10 lakh electrons are there, and there are 1000 holes only, so most of them are eligible to go towards the collector region. Okay, now what will happen? This is about the PN junction. So the more VB you apply, the more carriers will flow from the emitter to the base terminal, to the base region. Now, base region के बाद what will happen? Tell me, after base region, what will happen? Now see, collector terminal is connected positive supply, and negative supply is connected to the emitter. So basically what is happening is, base emitter, base collector junction is becoming reverse bias. How? अरे देखो ना, this positive supply is connected to N region, right? So it's negative. So base collector junction is reverse bias. So base collector junction is reverse bias. What will happen? Tell me. I am rubbing this out little. Tell me what will happen. There is a depletion layer, right? There is a depletion layer over here. What will happen now? Now you increase VCE. You go on increasing VCE. What will happen? More and more of these electrons, now they are over here. Now all these electrons are facing the base collector junction. This is my base collector junction. Now base collector junction is reverse bias. So बोलोगे reverse bias में तो current नहीं flow होना चाहिए. In this situation, the reverse bias is connected in such a manner that all the electrons are attracted towards the other side of the battery. Meaning, देखो, ये positive side of the battery है. These are all electrons. They will be attracted towards this, right? But these are not sufficient. These are just 10,000. Where is the majority number coming from? The emitter. Emitter में कितने? 10 lakh electrons. So 10 lakh में से, let's say 9,50,000 are flowing into the collector region. 9,50,000 electrons are going to the collector region, joining that minor, there's 10,000 electrons which are already present in the collector region. So they will become how much? 9,60,000. Is it clear? Yeah. So that's how your current, which is flowing from the emitter, goes through the base, reaches the collector. Once it reaches the collector, the current has flown from entire device, right? It has flown in from one part and entered out from the other part. That's why it's called as the collector region. You know, by collector region, all the majority carriers that are charge carriers are collected at the collector. Okay, emitter is emission of electrons, and collector is collecting the electrons. Okay, and these electrons will flow to the will be flowing into the positive terminal of the battery. So electrons are flowing out of the collector terminal, right? So a conventional current will be down, opposite of electron. So here IC will be flowing like this. Well, what will be about IB? IB will be flowing like this, and what about IE? Emitter current will be flowing out of the emitter terminal, because conventional current direction and flow of electron current is opposite. You know that much, right? So again, I revise. How does this work? Okay, fine. Remember, there are minority carriers also present, but there are so much majority carriers that it doesn't matter. But there are minority carriers in the collector region. Collector region mein there are 1000 electrons, but 100 holes are there. So there will be a leakage current also associated with base collector junction. Base collector junction is reverse bias, na? And in reverse bias we have leakage current. Forward bias there is no leakage current. In reverse bias there is a leakage current. Are you understanding? So this is how your BJT will operate in the active region. Little bit understood? No. And okay, I'll explain you one more concept is there. The base width is becoming even thicker, even thinner. Why? Because this is forward bias. Basically, forward bias is very, very small. Depletion region is very, very small, almost like this way. But as we go on increasing VCE, what is happening? The base collector junction voltage is becoming more reverse bias. And in more reverse bias, what will happen? This will increase now. Depletion region will increase now. So base region is becoming, this W increases. So this base region is becoming very less automatically because of the depletion layer. Now the active base region is only this much. So less number of carriers will recombine. So more current will flow. So what happens is, how the current can flow more in the device? Number one, increase VB. Number two, increase VC. Are you understanding? So very less current will be the base current, IB. IE will be the largest, and IC will be the next largest to IE. Okay. Also, one more analogy is there, that is 95% of these electrons. I have already given you this fact, right? 95% of electrons in the emitter are flowing into the collector. I told you this, right? Out of 10 lakh, 9 lakh 50,000 are going into the collector. Where are the other electrons? Some are lost in the recombination at the base terminal. Okay, and only 5% of that flow out of the 9% of the 5% of our electrons are being spent over here in the base region. 95% is flowing into the emitter. Okay. Also, in the reverse bias, what is the status of electric field? The higher the reverse voltage, the more powerful is the electric field. So, how is the electric field directed in the base and collector region? The electric field is directed this way, vertically down. This is electric field. So as you go on increasing VC, this electric field is becoming more powerful. So electrons, what happens is, all those electrons which are arriving at the base terminal, they will be pulled up by the powerful electric field, which because the space is very wide, and also the collector region is very large. Okay, and it is reverse bias, and it is more reverse bias. And when the PN junction is more and more reverse bias, the electric field will become more and more powerful. The powerful the electric field, the more rapidly it will pull the electrons coming onto the emitter into the collector, and hence contribute to the current conduction process. Okay, so what you have written, the principle of BJT, the voltage applied between base and emitter is controlling the current at the collector terminal, right? That is exactly what is happening over here. The VB voltage is actually controlling amount of IC current which is flowing into the circuit, provided you also apply VC voltage. Okay, so this is how, what is my input current? Input current is IB. IB is my input current, and what is my output current? Output current is IC. Now, do you agree that IB is very, very small? IB is small, right? Because only few of the holes are going and contributing to the current flow. Okay, so IB is very, very small. IC is very, very large. Basically, what happens is there are three terminal currents: IC, IB, and I. So IC is in milliamperes and IB is in microampere generally, 1,000 times lesser. I mean, milli to micro, when you go, it's 1,000 times difference, right? So base current is very small. What about the collector current? What about the emitter current? It's again in milliamperes. Basically, if you apply your KVL, KCL over here at the node, emitter current will be collector current plus base current. Okay, fine. So VB will control IB and IB will control IC. Now, can you agree that IC is very much greater than IB? Correct? So can I say output current is greater than input current? So output current divided by input current will be how much? Will be very high. And that is why it leads to amplification. It's the current gain. Output current upon input current is current gain, and that is called as beta of the transistor. Output current upon input current is beta of the transistor, and that is termed as, yeah, here it is, beta. Where it is written? Yeah. So beta is output current. What is output current? IC upon IB. This is called as current gain. And because of this current gain beta factor, it is eligible to use as an amplifier. Because this current, when flows to a resistor, it will create a voltage drop, right? And that voltage drop can be used as a voltage amplifier. All right. Now you can draw this diagram if you wish to, or you always draw it later. You have understood little bit of working. See, I have not revealed most of the details because you all don't have this in details. You all have just to understand the basic working of BJT, that's it. Or this will involve also energy band diagram. I don't want to go over there. Okay, if you have understood PN junction, if you have understood what happens in forward and reverse bias, this is how it will work. It's basically, you can consider, I'll give you an analogy. In a cricket match, the batsmen are standing in the emitter region and all the fielders in the ground are at the collector. So whenever a batsman hits, it will be going into the collector region only. Okay? And the pitch, the 22 yards is the base region. Are you understanding? So not every time the ball goes into the pitch, right? It goes into the outfield most of the time. So that is what is happening over here. In the base collector region, since it is reverse bias, there is a minority charge carrier called as ICO. That is also there. Okay? Yeah? So I'll tell you the sequence. First, you in the structure, you draw it vertically. Okay? Starting from emitter, base, collector. Emitter is heavily doped, base is lightly doped, collector is the largest area and moderately doped. Base and emitter, we have forward bias. Base collector is reverse bias. So here you connect the supply between collector and emitter because it is in the common emitter mode. So first, we increase the value of VB. So what will happen if we increase the value of VB? The conduction starts happening in the PN junction in the base and emitter region. Now, since emitter region is very heavily doped, most of the electrons cross the base region. Some of the electrons recombine with the holes in the base region. Most of them are eligible to flow in the collector region. Now, since collector terminal is positive supply, it is reverse bias base collector junction. Most of this emitter electrons flows into the collector. They join the electrons in the collector and hence contribute to conduction of current. Okay, which is the biggest current among the three? Emitter current. Which is the next almost equivalent current? So let's say emitter current is 10 lakh. What is the collector current? 9,60,000, as I've told you, and remaining is the 40,000 is the base current. Okay, This is how the BJT operates in the simplest of explanation. Completed this? Yeah. Now, beta, write down beta. This is very important. Beta is very important. Beta is called as the current gain. It's output current upon input current. Output current is collector, input current is base current. Also write down this expression. IE is equal to emitter current is equal to base current plus collector current. Okay. And emitter current is almost same as collector current. Almost, they are not almost same. Actually, collector current is slightly less than emitter current. So how much less is determined by this factor alpha. So there is one more relation. IC is alpha times IE. Actually, we will explain you. I'll explain you alpha when I explain you the configuration. Right now, you just understand there is a beta, which is current gain, which is very much greater than 100, and there is collector current related to emitter current by alpha. Okay. Now listen carefully. Listen, just last few minutes. See, IE is what? IE is IC plus IB, right? And what is IC? Beta times IB. So IE can be related to IB directly, 1 plus beta times IB. Understanding this? So please write this down. You should know relation between these currents. IC and IB relation is determined by beta. IC and IE relation is determined by alpha. IE and IB relation is determined by 1 plus beta. Okay? Okay, now one more time. IB plus IC is equal to IE, right? And according to the definition, what is IC now? Alpha times I. So you take IB over here, rest will be IE into 1 minus alpha. Okay? And what is IE again? IC upon alpha. So the relation between IC and IB is alpha upon 1 minus alpha, which is nothing but beta. Please write down these equations. Now written over here one statement, BJT is a current control device. How? See, base emitter voltage controls what? IB. And IB controls what? IC. So basically this is my input current, this is my output current. So what is being controlled by IB? VB. Okay. So basically IB is controlling IC, that's why it's called as a current control device. This is input voltage. Alright. So we stop over here. Next time we'll start with the BJT configurations. That time I'll tell you what is the definition of alpha and beta in more details. And we'll also study the characteristics of this BJT in all the three configurations.